Welcome to all students. Myself, Om Prakash Vadara, Assistant Professor, Principal of Seed Technology, Department Faculty of Agriculture and Veterinary Science, Jyoti Vidyapit, Women University, Jaipur. Today we discuss about our topic seed dryings. The process of elimination of moisture from the seed is called drying. Mainly, seed drying is necessary should reduce the seed moisture content to save moisture's limit to maintain its viability and vigor during storage, which may otherwise deteriorate quickly owing to mold growth, heating, and enhanced microbial activity. Seed drying also permits early harvesting, long-term storage of seed, more efficient use of land and manpower. The use of plant talc as green fodder and productions of high-quality seeds. Depending upon the climates and maintain of harvesting adopted threshing, seed may or may not be dry enough for safe storage. Under less favorable conditions, threshed seed need further drying. Stage of moisture eliminations. The moisture from the seed is eliminated in two stages. First, surface moisture of the seed that initially removed by the dry air. The removal of the moisture in surface causes an imbalance in the moisture's potential in the surface of the seed and the inner portions of the seed, which lead to the migration of moisture from inner organ to the surface. The migration of moisture to the surface is slower than the evaporations and moisture gradient is development in the kernel. Elimination of moisture from the seed depend upon the relative humidity and the temperature of the environment surrounding the seeds. When relative humidity of the atmosphere is less than the seeds, then moisture is eliminated from the seeds. While drying, care should be taken to minimize or prevent oxidation and decompositions and volatilizations. In this process, there will be loss of dry weight of seed, which is evident when the process takes place at high temperature. Hence, high moisture seeds should be dried at low temperature. Equilibrium moisture contents. A seed is in equilibrium with the environment when the rate of moisture loss from the seed to the surrounding atmosphere is equal to the rate of moisture gained by the seed treatments of atmosphere. Drying temperature greater the seed moisture content, then later should be the drying temperatures and vice versa. Mainly 10% and below 110 degree Fahrenheit or 43.3 degree centigrade. If 10 to 12% moisture content and then 100 degree Fahrenheit or 42.2 degree centigrade. If moisture content present 18 to 30%, then temperatures require 90 degree Fahrenheit or 32.2 degree Fahrenheit. The rate of drying depend on initial seed moisture content, size of the bin and capacity, depth of the spread of seeds, the rate of air flow, atmosphere air temperature and relative humidity or static pressures, drying temperature, etc. Method of drying, firstly, mainly physical drying or natural dryings or traditional sun dryings. After that, mechanical or artificial dryings, dryings with forced natural air, drying with forced artificial heated air, or drying with desiccants. Drying with the infrared rays, physical drying and natural dryings or traditional sun dryings. This is the common conventional methods in which drying of the harvested crop is carried out in the fields or threshing floor by the radiant energy of the suns. This does not involve any expenditures to achieve uniform drying, so the seeds should be spread in thin layer. High moisture content seed with a moisture content of more than 17% should be dried first under shade after light to reduce the moisture content less than 17%, and then dried under heavy suns. Noon drying sun dried seed should not be allowed to remain in open floors during nights since the seed will absorb moisture from air 2 to 4 days are needed to reduce the moisture content to 10 to 12%. Direct sunlight also can adversely affect seed germinability, owing to high temperatures and ultraviolet radiations, especially if the moisture content of the seed is high. Advantage mainly easy and cheap. After that, does not require any expenditure or fuels. Disadvantage mainly the rate of drying is low. The loss due to attack by insect, birds, and animals. Large floor area is required. Say, involve extra labors for collecting and exposing during the day. Sun drying causes sun checks or photosports due to variations in temperature from time to time. These checks or sports induce high amount of breakage while processing. Mechanical admixtures are possible. Dust and dirt are foreign materials get mixed. High weather risk and damage by heavy wind and winds. Mechanical drying or artificial drying or forced air drying in forced air drying natural air or air supplement with heat is blown through a layer of seed until drying is completed. Generally, ordinary sheet godowns are provided with two types of ventilator for free movement of air circulations. In modern godowns, provisions are to be made for forcible circulations of air with the help of an electronic blowers. The outside air, which is comparatively dry, is circulated in the godowns and thereby the seed get dried up in the process. This is possibly only dry months. Two type of dryers are used as batch and continuous flow dryers. In batch dryers, relatively dry air is blown through a layer of seed until seed is dried completely. After which it is removed and replaced another batch of the seeds. The method is simple and well suited to small quantities of the seeds. Allow easy cleaning and recommended for farm drawings. In horizontal dryers, the seed is contains in a box or chambers with a purported floor through which the air is blown. Air ducts can be installed in a barn floors and the seed to be dried laid over them. In a modified sex, dry seed contains in a oven sex is placed on a grid through which air is blown. Continuous flow dryer in this type of dryer, the seed moves horizontally or vertically through a stream of hot air and then into a cooling chambers. These dryer are however difficult to clean when there is a change of cultivated variety. This dryer can use air temperature higher than those of batch dryers because the seed is heated for a much shorter times. LSU dryers, Lausania State University dryers. This is a continuous column heated air dryers, largely used for paddy. The paddy seeds are fed from the top with the help of gravity force in zigzag manners. And heated air is blown from the bottom, usually at right angles. So directions of seed motions, the falling seed get dried up by the heated air, and this process is repeated till to get reductions of moisture content to the expected levels. Non-mixing column dryer. This dryer consists of a tall vertical column through which paddy flow by gravity. No provision is made for agitating the paddy as it follow, and hence there is no attempt to drag the paddy from straight wedge. Paddy descends gradually between two parallel screens and heated air is forced through the screens. Advantage of our wind dryers, firstly, so drying creates less damage or spoilage during wet weather. Drying is more uniform. Advantage of mechanical drying method, timely and uniform drying is possible. Make early harvest possible. It reduces the chances of losses due to overripening and shattering of seeds. Losses due to rodents and birds are prevented. Less damage during processing operations. and permit long time storage by preventing sun checks and other damage. Disadvantage mainly initial cost of trying the equipment is very high. Fuel is very expensive and it produces possible fire hazards. Considerable supervision is very necessary. A storage structure for seed drying mainly building requirement for a seed drying systems depend upon the size of the operations, the number of different sheets to be dried, the level of mechanization desired, and future expansions. Different types and forms of storage structure can be built for handling seed to be dried with forced air. These may be made of steel, wood, plywoods, and concrete, and they may be cylindrical or rectangular in shapes. Regardless of the type of structure, all storage bins used for post air drying in storage of seeds must have the following features. Small grain sheet in bulk exert large pressure against the side walls. The side pressure are converted to a vertical load on the foundation, which should be strong enough to hold the seeds nodes. The roof and walls of wings must be airtight for drying to proceed the satisfactory. The opening for filling and removal of seeds should be large and convenient to use. A full-size entrance door is desirable. A hand space about 1 meter should be provided for easy instructions of seed cleaning and spraying operations should be convenient for fumigations. The structure should be airtight with provisions for temporary sealing of the all openings. The structure should be able to dry and store more than one kind of seed. The triangle should be uniformly distributed through all the portion of the seed plot for efficient drying. Air distribution system. Agarwal described three types of air distribution systems used for seed dryings. The main and lateral duct systems, a single central perforated duct, and the perforated false floor systems. Multiple bin storage structure for drying can be built so that they are arranged to enable the drying of several sheets loads simultaneously using the same drying fans. Alternative different sheet loads can be dried successively with sliding air gates controlling the flow of air to the respective bins. A multiple bin arrangement is particularly useful to dry more than one kind of seed simultaneously. Heated air drying systems. Heated air drying consists of a heater unit where fuel is burned and a fan to force the heated air through a canvas connecting duct into the air distribution system for the drying bin. Safety features such as automatic thermostatic high limit temperature control, which cut off the burner flames if the air temperature exceeds a certain set maximum, and flame failure control, which automatically cut off fuel flow to the burner if the flame goes out are provided. A thermostat can also automatically maintain the air temperatures at desired settings. In many dryers, such thermostats are provided as standard features. The dryer are designated to burn various types of fuels, example liquid propane or butanes, natural gas, fuel oil, and coals. Both liquid propanes and natural gas burn readily with minimum soot and are the best fuels for direct dryers. Ah, हाँ